So today's task is to fit the Victron Shunt. It's a function that I've wanted for a long time, so I'm going to try and get that fitted into the van this morning. So I've got the Smart Shunt, but not the IP65 version. Can't quite remember what IP rating it's got, but so it's the original one. Okay, I've just made this cable up. It's a bit longer than I'd intended, but the height of the shunt is obviously different from the height of the ground bus bar. So rather than actually just have it running parallel, which was my plan, I'll just have it like that. And there's no stress on it. It's big enough that there's not any stress in the terminals, and it will count for the height difference. I don't know how well you'll be able to see that. I'll do my best to make it possible. It's quite tight where this is, and also to get the angle for the camera, so hopefully you can see it okay. It's a 19mm socket, 18mm socket for the nut and the bus bar, and it's a 17mm socket for the nut on the shunt. So just switching over. So this is the Victron lead that comes with the shunt, so it's obviously a very low power or current, low power, low current draw, and it's got an inline fuse. So I'm just running this through to the battery, and then I'll get that wired up and get the power back on, and we'll do a wee test. Find it. Okay. So for the moment I've got this circuit breaker. I am thinking about replacing this. I've read kind of mixed reviews on it, so I think I'm just going to put a MIDI fusing line and actually add an isolator switch. I'll do that probably at the same time as I do the positive 12 volts bus bar. So for the moment this is the supply from the battery through that, and it just goes to the electrical systems. There's not a high current draw from this. Yeah, the inverter is connected direct to the battery, so that's got a 240 amp cable and supply there. So I'm going to connect the shunt to here, so I can still isolate it if I want to, until I upgrade with the isolator switch like I've talked about. So we'll get that done for now. And that's obviously completely overkill. I've left my snips in my toolbox back at the hut, so I'm just trying to save a walk. Not a mess, wasted a crimp. Not good. Tie wrap that on there for the moment, just to keep it a bit tidier. And as I say, this is temporary, and then when I install the 12 volt bus bar, I'm going to actually improve all of the 12 volt wiring. Okay, happy with that. Okay, well, that's a good start. See that, but in an instant it came up with a shunt. Okay, so we're on an update. It's quite a hard angle to get into the camera, but that's the shunt installed there. And this is basically the connection from the 12 volt bus bar into the shunt, through the shunt, and then from the battery negative, the battery ground, back to the battery itself. So I'm quite happy with that. The solar's got the battery and flow it. I'll probably also put the Victron power supply on the battery charger, which is just located here, just to double check everything is absolutely fully charged, and then I'll set the shunt to 100% capacity, and I'll just check all of the settings as I do that. I've already set the battery capacity to 220 amp hours, So I think we're nearly good to go, so I'll leave it at that for now. This is an experiment just to learn a bit, test things out. So the laptop's looking at the smart solar controller. So we've got a bit of solar, we're in flow, so pretty much just in standby. Have been for many hours, have been for many days, so that's all very straightforward. The solar's not working at the moment, there's no load. And my iPhone is looking at the smart shunt, so again there's negligible load, it's 100% state of charge, everything's fine. Now we've got an inverter fitted. It was fitted when we bought the van. It's a low cost one, it takes a massive current from the battery. I want to actually switch that on, plug in the hairdryer and just see the differences. So that's the inverter on. There's currently no load being drawn from or connected to the inverter, but we've switched to put 3.2 amps from solar into the battery, and there's still no load obviously. So I'll plug in Wendy's hairdryer. Well, it's probably pretty difficult to hear me now, but the solar's harvesting what it can into the batteries, and we're looking at 111 amps being drawn from the batteries to supply the hairdryer. So that peaked at 1,305 watts. Yeah, and it says the hairdryer is 1,400 watts. A lot of current coming out the battery, so you can really see the time remaining dropping quite significantly. And the solar's now switched into bulk, now we've taken a bit of power out of the battery. So 105 watts going in, nearly 8 amps. So this is another test with the fridge running. So it's a compressor fridge, so the 12 volt batteries are supplying that. The solar is supplying about 9.5 amps to the batteries, and then allowing for the consumption of the fridge, which I guess is taking about 4 amps. That's then 5.8 amps flowing into the batteries, and that's been measured on the shunt. So the next thing I did was to power up the Victron 12 volt charger to get the benefit from the 5 charging stages, and I just left it charging until the batteries went into storage, and that's what's shown here with the batteries in storage, and it just shows how much current, how many amp hours were required in that charging cycle. So this is measured from the shunt, showing that the batteries are fully charged and there's no load, so there's no current being drawn from the batteries. I think I've replicated the settings on the shunt, configured that as pretty much the default. So I've got 2 lead acid batteries, so the pure exponent or pure constant reflects that, and I've mimicked the default settings for the moment. I'll have a good study of the manual and try and just check I've got this as optimised as I can. So electrically installing the shunt is really quite straightforward. It was easier in my case because I'd previously installed the ground bus bar, and I covered that in a previous video.